Hello everyone, welcome to the channel and I hope everyone is doing good. So in today's video, we are going to look into another project of MCP where we will be dealing with the databases. So in the previous project, we have seen the MCP project in which we have connected to the Wikipedia API and multiple requests were written, that logic were written in the MCP server. So in this particular project, we are going into the SQLite. We are using SQLite DB to perform all the database related queries like insert, update, or list of the records. So overall architecture is like user will submit the request to the AI client. Okay, so in my case, the AI client we are going to use the LLM as it here, and then there will be MCP client which will take the request. It will call the tools, or it will have the list of all the tools. Then there is a MCP server which have all the tools definition, and there will be one layer which is called business logic layer where all the SQL related logics will be written. So we call it a business logic. And finally, that will be the request will goes to SQL DB. All the user request, like for example, insert the record, will be performing here, and then it will be returned back to the LLM. If you're not subscribed to the channel, then please do subscribe to the channel. If you like my video or channel, then do spread this video and channel to your friends who want to move into data engineering field, or who are already a data engineer and want to move to a Gen AI field. So we'll start with this. I have already done the setup in the VS Code. I'll show you the setup. Setup is very simple. There is a client code. There is some configuration code. I'll come to that. There's a database code. There is some thing which I have to create while starting the project. Then there is a LLM code. There is a model code which is the business logic code. And I tried to create the prompts PI, but this is not working. So we'll remove this now. Then we have a server code. Okay, so now we'll look into each of these things, and you can also create such kind of application in MCP. So first is my database. Okay, so we are going to use SQLite. So we have used SQLite in this project. So SQLite is a normal file-based database. You can easily create in the mobile application, in the small application. This is not like a traditional database like Oracle or MySQL or the Postgres. This is a file-based. The file contains all the information. It's easy to do some kind of POC or a small project, or a mobile application. Most of the mobile application also use this kind of database. So there is a init file, means this is the first file just I have created. You can run this. So the purpose is we have created a database, and we have created a table here, employee table. So database is employee.db, and the employee table in which we have this column ID, employee ID, name, department, salary, and email address. Fine. So this database will be created. So I have already created database. You can run this one. Then we'll go to database.py. So this Python file, like it's making the thing more modular. Like every time you want to connect to the SQLite to create the record or do any of the SQL functionality through MCP. So there, you don't have to every time write connect to the database. You don't have to write the name, write this code. So this function will be called whenever you want to get a connection to the database. Okay. So this actually that concerns to connect to the database for each of the file, that is removed and made modular, and this is how generally in a normal production based project or any of the company based project the structure will look like. So this is a database. Now we'll go to the business logic. So business logic is there in the models.py. So you can see here. So I have written here business logic. So your business logic, for the business logic, I have created a Python file which is model.py. Okay. In this, all the logic for the SQL has been written. For example, uh, create employee. So you want to create a record. So insert statement functionality is written in this function, create employee. Okay. Then we have get employee, means you want to do the select query. So that select statement is written. Similarly, if you want to search an employee, so for searching the employee is also written. So like clause is used here. Now you want to update anything. So for example, you want to update the salary. And if you want to update the name, generally you don't update the name. So you update the salary, or you want to update the email address. So you can create a different function for that. So you want to delete the employee. So that option is here. you want to count the employee count, so select star from the table, that is also done. Then you want to get the highest salary. So these guys, all kind of SQL functionality is written here. Now remember this model.py, which is actually the business logic file. This file has nothing to do with the MCP. It has nothing to do with the AI, nothing to do with the LLM. This is a basic business logic file. Similarly, this database.py, ini.py has nothing to do with the AI MCP. Right. So this model.py contains all the business logic. Now we'll move to the another file. Now we'll go to server.py. Okay. So if you would have seen my previous video, so you'd be knowing that in server in the server code, we register all the tool. Okay. So now you see there's a function called add employee, and that has been registered to MCP server. So actually we are creating the MCP server, and that for that we need fast MCP. Okay. And you need to install that. So all that process you would have seen in my previous video itself. So now what you will do, you will create a tool. So add employee. So how to add an employee, and that logic is written here, and that is in will link with the business logic which is written in the model.py. And with the help of decorator, we tell that MCP that this is a tool, register this as a tool. So MCP server will have the metadata information about this function as a tool, what is the input parameter, what is the output or return time. Similarly, this is one of the tool. The other tool is list employee. So all that tool what you mention here should have the logic somewhere. So for add employee, we have the logic in model.py. Right. Similarly, we register. If you don't add this line, this decorator, then MCP will not understand this as a tool. And once you write this decorator, MCP understand this as a tool. It creates it as an independent entity, and then LLM or any of the AI tool and the AI model will be able to find this. Now, the good thing is, now when you register everything in MCP server, so your client, or when you want to see what all tools are available, you don't have to write this tool name or hard code this tool name in the client code. In the MCP client code, when you do the list tool, it will show you all the list of the tool. I'll go to the client code. In the client code, you will see here, when we do the MCP tools or when we do the list tools, so we are not writing the list of the tools. Okay, so this will get all the tools information from the MCP server. And how MCP server will know all the tools? Because in the server code we have registered this all function as an MCP tool. So this line is very important to make this understand as a tool. And this is the very big difference between a function call and the tool what we create in MCP. Once we have all the tool registered in MCP server, then we can deploy this MCP server into any of the application, and that application MCP client will understand what all tools it has. That doesn't happen with the function. So function call and MCP server tool calling is very different. So now one more thing I want to mention here, like I mentioned in almost all the videos of my MCP, like when user write the query or when user give the query to your AI application where MCP is being used, that query don't get directly to the MCP client. First, it gets into the AI system. Okay, AI, any of the model. If you're using cloud, if you're using LLM, or if you're using any of the model. So first, like we are using GPT here, so it goes to the GPT model, and then that GPT understands what your query is. So that logic is written in the llm.py. So in this llm.py, the model, like for example, I'm using GPT model. That model doesn't know that what is the logic in the SQL, what SQL use, or where the database is. Do database exist or not? It has no information about the about the databases or the SQL. It gets the query like add particular employee to some database. Then this model understand this natural language, and from this it understand that which tool it has to call. LLM model will tell the MCP client that which tool it has to use, so MCP client has list of the tools, but MCP client don't have the brain to understand that which tool it has to use. So who gives the brain to the MCP client? Your your LLM or the model gives that particular brain, the thinking power to the MCP client, that which tool it has to use. So now we'll understand the client.py. Okay, so in the client.py first, now one more thing, like when you initiate the client.py, the client.py will call the server code also. Like in our previous example, in the previous video, I've seen that for the server, MCP server, you don't have to start the MCP server manually. When you start the client server, MCP client, so MCP server automatically gets started, and that logic is written here. If you see, the communication channel between the client and the server is created here. And when you create the session, so async with a standard input output client server, with this line, you start the server.py. So here I have mentioned server.py, and two stream is open, read stream and write stream. It's like you're calling a phone call, and both the party is saying hello to each other. That means now these two parties, the client and the server, is ready to communicate with each other. Fine. Now you see everywhere it's written async or async. Why it's written async? Async with the client session. Async means this client call is always asynchronous, because client calls the LLM, then it will call the server, and then it has to wait for the output. That that wait calling and waiting, it will call multiple times the LLM. It can call it parallelly also, and it has to wait for that answer. And so this is asynchronous call. Okay, so now it's written MCP initializing. That means your server has started, your session has been initialized. Okay, and now you get all the tools. See, this is the client, this is not the server code, this is a client code. And in the client code, you are getting all the available tool. We are doing session dot list tool. We are not sending the message to the server and asking for the tool. With this session, we have created this session here, read stream and write stream, with the client, with the server. And this session, with this session, we are going to get the list of tools. So this MCP underscore tools will have all the list of the tools available in the server. Okay, now there's an now OpenAI and the MCP SDK and OpenAI format are different. They may have a different way of communicating to each other. So we have to convert these two messages. One can have a JSON format, one can have a plain format. So to convert or to understand, like OpenAI, or we are using the ChatGPT of OpenAI. So I'm just telling it here, OpenAI. So to understand the message of MCP, the OpenAI, and what OpenAI sent to MCP, to understand that message, like both the party MCP and the OpenAI, to understand each other's message, we need to convert each other messages. So for this, we call this function, and this function has been written into llm.py. So how to convert? So this logic tells about converting each other's messages, so that your OpenAI and the MCP can understand each other message. Because MCP client is going to interact with LLM for most of the things. Like MCP client don't know that it has got the list of tool, but it don't know which tool to call. So then MCP client will ask the LLM that these are my list of tools, and this is the user, this is the message given by the user. Now you tell me which tool I have to call. Fine. So for that, it goes here. Okay, now it has all the available tools. It gets the input from the user. This is the message what it gets from the user. Okay, the content and the user. Now this message is passed to the ask LLM. Okay, so, and to the ask LLM, the message and the tools are being given. Like this is the message from the user, and these are the list of the tools. And ask LLM has been written into llm.py. In this, it receives the message and the tools. Now LLM has the message and the list of tools. Now LLM decides like which tool it has to call, or which tool is appropriate for this message. LLM doesn't call any tool, but it tells that this tool needs to be called. Now that message and which tool has to be called is returned to the client.py, right? So this message is received, and this message calls the tool. You will see it here. Okay, session.call tool. Then now this is getting, the session is used for communicating to the server. Now the server is being told that this is the tool name and this is the argument, this is the message. You have to initiate that tool. Now you see, your client doesn't know that what is the SQL behind that tool. Your LLM doesn't know that what is SQL inside the tool. Uh, Only your server knows that what is SQL or what is the logic inside, business logic. So your business logic is always independent from the client and the LLM what you are using, or any of the LLM client. It is only tightly coupled with your server code. And it needs to be only coupled with the server code, because you are defining the tool only in the server. You are not defining any of the tool definition in the client or in the LLM. That lies only in the server. So now you see message.append message. And now once it calls the client, it gets the return here. Okay, that its return type, and that message is updated, and that message has to again get into the LLM. Once you get the message out of the server, that message has to get into the LLM, because final answer your LLM will give. So client doesn't give the any answer. Client has the list of tools. It asks the LLM, this is the message, these are the list of tools, tell me which tool to call. The LLM returns that message to the client, that this is the tool you have to call. Now that client, MCP client, tells the server, this is the tool you have to call. Server execute the tool, it gets the output, and then client again form that message, gives that MCP client gives that message again back to the LLM, and tell the LLM that this is what I have got the return. You asked me to call the tool, I have called the tool, and this is the output. Now LLM will format that message in a human readable format, and it will give you the output. I hope this is clear. MCP client does nothing. It has the list of tools. It has the message. It asks the LLM what needs to be done. LLM tell this tool need to be called. Then MCP client calls the MCP server. Key that you just execute this tool. It gets the output from the MCP server, gives the output to the LLM. Like, these are the output which I got when you asked me to call this tool. And LLM will format the answer and give the answer in the human readable format. I hope it will be easy for you to understand. And in LLM, I have written all the logic for converting the tool, which creates a unified way of understandable message between the OpenAI and the MCP. And there is an Ask LLM, which gets all the input, like what are the message tools, or what the MCP client return from the MCP server. All this thing is there. Okay. To databases, for database in config, I have just given the OpenAI key. OpenAI key actually I have defined in the environment variable. I have to change this because I've deleted the key. I'll change it and I'll run it now. Fine. Okay, so model contains the business logic. Prompts, I have not started working on it. It was not working, so I didn't include it in this project. Okay, and now I will execute. So what I need to execute, I need to only execute the client, because client already have the server. Fine. So what I will do, I'll go to the, okay, first I have to change the key, OpenAI key. Okay, I have changed the key. Uh, Now I'll be running this client. So initializing MCP means it has started the server. These are the available tools, because in the client, the code is written to give the list of the tools, print available tools, right? So it is printing all the tools from here. MCP tools or tools. It gets the MCP tools. Already got the tools information from the MCP server. This session is used to talk to the MCP server. So for example, I will just give add underscore employee. Okay. It's return the, okay. It will give you an example also how you have to do. Now I'll just add employee Jan name. Calling MCP tool add employee. Okay, so the tool is, so if AI cannot add the employee because email already exists, and okay, already I have added it when I was testing it. So what I will do, I will just write it again, and this time, okay, will not go back. Okay, it will again say that which tool, add tool it is calling. And I'll just maximize. But the database credits for the employee could not add. Please try again. So there's issue with the database. Okay, I need to check it and then I'll come back here. So there was a problem with the initialization of the DB. So I have again created the database. So I'll do one thing. Okay, I'll again create the database. Let me do it in the database created successfully. Now I'll call the MCP client. Okay. Now these are the available tools. I'll just put it in a simple language like add employee Rahul. So let's see how it will respond back. Uh, Please provide Rahul details. So it's not asking the Rahul name again. It's asking the department, email, and salary. And this is the intelligence which we get from the LLM. Okay. So department is sales. Email is ab@gmail.com. Anything you can write. Salary 1000. And I think, okay, now I'm giving it, I think the format is wrong. Let's see. If I give the wrong kind of information, what how it goes. Please provide the employee's name so that I can find I can add it. So I will write here, Rahul. Find employee, no employee found Rahul. Okay. Now I'm asking to add the name. It is looking for that Rahul name. Okay. So now I'll write it here. Add the employee Rahul. Okay, fine. Then I can add, sure, please provide Rahul's email address. So I'll do one thing. I'll write in a proper format now. Rahul. So every time it gives different kind of answer. ab@gmail.com. And then department is sales and then salary is 1000. See, it's calling the employee, add employee, adding employee, Rahul successfully, employee it is given its auto incremented employee. Now, if I want to list all the list all the employees. It's calling total employee. There is nothing, no tool called total employee. Okay. So sometimes like it is not able to understand this list is equal to it has to call list employees. It has started calling total employees. So this is a like in the when you're using AI assistant, there are the chances like sometime it will not answer as expected, and this is one of the example. So I'll write it here the exact tool name list employees. So now I'm asking to call this tool list employees because see all this employee list is here. So how it got this information that this is the tool name because I have this tool name. Okay, fine. I hope you will be able to understand this. If you have any doubt, please post in the comment. I'll just put the solution there. And then I'll come with another video of GitHub Copilot. And in earlier video also I mentioned about that. Till then, any doubt, please post in the comment. Till then, goodbye and happy learning.